in coordinate geometry, and this topic is the distance formula. So it might be a good idea to warm up first. So we're kind of dealing with squares a lot in this particular topic. So let's warm up with just some regular squares. So 4 squared plus 3 squared, what's that equal to? Try doing it without calculator. So 4 squared, have a guess. Yep, you probably had it right. Plus 3 squared, and basically just add them together, and you probably got 25. 5 squared, you're probably guessing, is 25, plus negative 2 squared. So by accident, some people might think it's negative 4, which is incorrect. Negative 2 squared means negative 2 multiplied by negative 2, and remember, a negative multiplied by a negative is a positive. So then we'll get 29. 7 squared minus 6 squared. So think 7 squared, what's that without a calculator? Minus 6 squared. So minus 36, and then do the subtraction in your head. Let's see, did you get the right answer? 13. So moving on from there. Similar to the trigonometry unit, we want you to label the hypotenuse in this triangle. So we've got 2 legs, and you probably remember that the hypotenuse is always the length that's opposite the right angle. So you might want to colour that one in. So hypotenuse, by definition, it's always the longer side of the right angle triangle, and it's always opposite the right angle. So let's label this hypotenuse. Lovely. And something, let's make a little note of that. So the hypotenuse is always opposite the right angle, by definition. So let's write that in, just to remember that. Because sometimes people, I notice in the trigonometry units, sometimes people are still not quite understanding this concept, and they're thinking that this one of these other sides of the hypotenuse is the hypotenuse, but these are legs. Okay, so state Pythagoras' theorem. Probably remember it. And the reason why I'm getting you to do this is it relates to this particular topic we're about to do. A squared plus b squared equals c squared, where c is the length of the hypotenuse and a and b are the legs. Use Pythagoras' theorem to find b. So you've got to decide, first of all, is b, is it a hypotenuse, is it a leg? And you probably guessed, yes, b is a leg. 5 is a hypotenuse. So we can put it straight into Pythagoras' theorem. You could just go b equals square root 5 squared minus 3 squared and put that in the calculator. That's fine. I just happen to have done it right from the beginning. I just wrote 3 squared plus b squared, the sum of the squares of the legs, equals the square of the hypotenuse. And then I worked out what 3 squared is. We still got plus b squared. 5 squared is 25. Then I started to rearrange. We need to subtract 9 from both sides. So we say b squared equals 25 minus 9. And then work out what that is. What is 25 minus 9? I think, yep, 16. And then you just take the square root. So by definition, the square root of 16 has 2 answers. The 2 answers are positive 4 and negative 4. But because we're referring to a triangle, we can't really have a negative length in the real world. So we'll just say it's positive 4, even though technically there are positive and negative answers. But because we're relating it to a triangle, there's only a positive length is possible. So 4, and there's no units, so I just wrote units. So let's move on to the lesson, the distance formula. So let's mark 2 coordinates, x1, y1 and x2, y2. Throughout this whole unit, you'll hear me going on and on about x1, y1, x2, y2. So meaning the first coordinate and the second set of coordinates. And a coordinate always has an x coordinate and a y coordinate. And we put the coordinates in brackets and we put a comma in between them. So x1, y1, let's see, you just pick one of them. So I decided to do x1, y1 in red. So I've decided, okay, let's call the first one x1, y1. So what you do is you just label it. Put a little red dot, label it x1, y1. So therefore the other coordinate at the other end will be this one, x2, y2. So I'm going to label that in green, mark it in green and label it x2, y2. So remember, you have to use the brackets if it's coordinates and you have a comma in between the two. Also our little x and y axes, they should be labelled too. So that's been done. So according to Pythagoras' theorem, a squared plus b squared equals c squared, we can potentially kind of express this in terms of Pythagoras' theorem. So notice we kind of form a right angle triangle. You're marking the right angle there. So here is a leg, here is another leg, and here is a hypotenuse. So to find a formula for D, we're actually going to kind of prove the distance formula. The theory behind the distance formula, which we haven't learnt yet, is Pythagoras' theorem. So we're going to discover it for ourselves. Try to think what would be an expression for the horizontal distance here. So this bottom leg, what would be an expression in terms of x for this horizontal distance? When you think of it, this point here would be x1, and this point here would be at x2. So the distance between them would be equal to x2 minus x1. Do you agree with that? And then the distance here would be equal to this coordinate, or this x coordinate, minus that x coordinate would give you that length there. Similarly, an expression for the vertical leg would be the distance between its y coordinate and the bottom y coordinate here. So this length here would be equal to y2, which is this point here, minus y1, which is that point there. If you do y2 minus y1, it gives you that length. And then to plug that into Pythagoras' theorem, we'd have to take the square root of this leg squared plus that leg squared. And by that, we can plug it into Pythagoras' theorem. So we can say that the distance, or you can say D at the beginning if you want, is equal to, you'll need a big square root sign. So a big long square root sign to begin with, to put these expressions in there. And remember, we'll do the first leg. What was the expression for this one? It was x2 minus x1 gives you that distance there. So we need to show the square of that. x2 minus x1, in brackets of course, all squared. So that's the length of the bottom leg, and plus the other leg squared. And remember, the other leg, its length would be y2 minus y1. So let's put that in brackets. y2 minus y1, all squared. And what we have here is the distance formula. So this is the distance formula, which you've just proved yourself using Pythagoras' theorem. So now you know where this comes from. We'll be just basically using it. You don't need to kind of show the proof in your test or anything, but it's just good to know where it came from. The theory behind it is Pythagoras' theorem. So this is the distance formula we'll be using. So basically, the distance, so here's your 2 points, the green and the red point. So what it is, it's a formula for calculating the distance, this blue distance here. What is the distance between these 2 points? The theory is Pythagoras' theorem. And so if you were given the coordinates x1, y1 and x2, y2, you could just plug them into the distance formula and calculate the distance between the 2 points. That's the whole point of this formula. Okay, so let's try applying it. So D equals square root, again, x squared minus x1, x2 minus x1 all squared, plus y2 minus y1 all squared. So notice it's just the sum of the squares. So if ever you forget it, it is, because remember this is not in the formula sheet, unfortunately, like you've just got all those geometrical and trigonometric formulas on your formula sheet in the exam, plus the quadratic formula, but you don't have this, you have to know this one. So it is kind of easy, because just try to remember it's based on Pythagoras' theorem, so it should look like you're doing a Pythagoras. You'll find your hypotenuse. So distance equals square root of the sum of the squares of the 2 legs. And one leg is horizontal, so it's been worked out with x2 minus x1. The other length is vertical, so y2 minus y1. And notice we have to have the second one first. So 2 minus 1, 2 minus 1, and they're both squared and added together. So you can still just remember it yourself. So let's try applying this distance formula. Find the distance between the points 1, 3 and 4, 1. So what I'm always going to be doing, and trying to remind you to do, is always to label your 2 little coordinates, x1, y1 and x2, y2. And I find if people don't do this, they tend to put the wrong one in the wrong place. So if you just try to do it off the top of your head, sometimes people will do x2 minus x1 here, but then they'll by accident do y1 minus y2 here. And it's got to be set up in this order. That's really important. So we would have to put in x2. So the good thing about it is you can easily see, clearly x2 is what you've got to put in first. Just go straight there, it's 4. Minus x1, it's 1. So the advantage of labeling it is it's so easy to then substitute it into the formula. So just go d equals, do big square root, because sometimes people do forget the square root, not that often, but occasionally. So you might want to start with just a big square root sign to begin with. And your brackets, so start to do your bracket. And then x2, which one is x2? So it's because you've labelled it, you're not going to by accident put in x1. So x2 is this one here, it's 4. So 4, and it's minus 4 minus x1. Have a look here, which one is x1? It's here, so it's 1. Don't forget to square it as well, very important. Plus, open bracket. Now what comes next? y2. So y2, where is it? It's right here, it's 1. 1 minus, what comes next? y1. Which one's y1? It's that one. So see, by having it labelled, you're just not having to think so much about which one's x1, y1's, which one's x2, y2, and so on. What's really lovely is you don't need to do any working out in between. This could be your substitution step, which you get a method mark for. I would strongly recommend doing this, because if people try to do the maths in their head, they tend to make mistakes. So a pure substitution step like this is really great for the examiners, because then we can give you a method mark. And then the great thing is you can plug it straight into your calculator just like this. There's no need to do any particular working out, because your calculators have nice big screens and lots of functions, so you can type things in. So you can type it into your calculator just like this. So maybe remind yourself of that, put a little note so that you don't think you need to do any maths in between this and the answer. Just to prove that, if you like, I'll do a little proof of how that works. So say if you have your Inspire, it's a similar thing, but if you're doing the old GDC way, square root sign, and then 4 minus 1, so 4 minus 1, brackets squared, plus, oops, plus what comes next? Oops, sorry. So 4 minus 1 plus, and then it's 1 minus 3. 1 minus 3 squared. Just check, have you substituted it incorrectly? Does it match what you've got down here? Let's see. That's what we've got. So similar to your other units, definitely I would strongly suggest write out the unrounded answer first, because you might need the unrounded answer for a later question. So write out the unrounded answer first, and then after that round it to 3 sig figs. So this rounded to 3 sig figs would be 3.61, and I don't have much space to write the unrounded version. So I'm just going to write the rounded version. So the distance between these two coordinates is 3.61, and there is no unit so far, so I'm just going to write units. Just a reminder to always round to 3 sig figs, which you're pretty good at doing. But on top of that, you might also make a note, write your unrounded answer first. So round to 3 sig figures, the 3 significant figures, but don't forget to round to write the unrounded answer first. I didn't have much space to do that, but hopefully you've got more space on yours. And that's it, it's done. So we need the substitution step and the answer unrounded, and then rounded to 3 sig figs. So find the distance between these two coordinates now. So this is a good one to practice because you're dealing with negatives. So how does that go into the calculator correctly? So what should we label these first? Try to think. Yep. Dear me. X1, Y1 is this one, and so therefore the other one is X2, Y2. I just go in that order, doesn't matter. You can do X2, Y2, X1, Y1, but why not just do the first one and then the second one? So let's remind ourselves to always do this labeling. It's so helpful, and it seems to really reduce the amount of errors that can happen. So always do this labeling. It's a great idea to make a note of. Now let's set it up. We've got distance equals, and our big square root sign, because it's going to be big long square root. Goes on and on and on. Alright, and so the great thing is we can open our brackets and we've got everything labelled, so it's really easy to see what goes in there. So the first thing, if you've forgotten the distance formula, it's up here. X2 minus X1. X2 is -1, so make sure to get your negatives correct. -1 minus X1 is -3 minus -3. So don't write -1 minus 3, it's -1 minus -3 plus y2 minus y1. So y2 you can see is negative 4 minus y1, which is negative 2, all squared. This goes straight into your calculator like this. Can be a bit awkward, so just go really, really carefully. So what do we plug in? I'll do it on here, just to show you that you can plug it in just like this. So open your brackets, and it's negative 1, so I use the negative button instead of the minus. Negative 1, but then it's minus, use the subtract button, negative 3. Close brackets, squared, so it can be a bit awkward. Plus, open brackets, so it's negative 4, so use the negative button, wherever your negative button is on your calculator. If you've got the Inspire, it's somewhere else. And it's subtract, negative 2, all squared. Don't forget the square. So you go straight into the calculator, just like your substitution step. Write out your unrounded answer, so write out 2.824 and so on, and then round to 3 sig figs. So 2.82, but then the 8 rounds a 2 up to a 3. So you have 2.83 units. Again, you write your unrounded answer first. So what's really important though, unrounded answer is just a good idea because you might need the unrounded answer for a later part in the question, and also if you make errors in your rounding, because if you have the unrounded answer, maybe they won't penalise you for having errors in your 3 sig figs answer. So you'll get your method mark for your pure substitution step, so that's why I strongly recommend you don't do this maths in your head to begin with, that you just write it out perfectly like this, so they can give you a method mark. And then answer mark is what we have here. Method mark, answer mark. Now let's go into the next page. Some more examples. Find the distance between negative 2 and 1 and coordinate B, 3 and negative 4. Looks like this is missing a comma, is it? Okay, so I'm going to put that in because that's bothering me. So that should have a comma. Remember, coordinates should have little commas between them. 3 and negative 4. Okay, so what do we label them first? That's right, we label x1, y1, make sure you do that, and x2, y2. It's just a nice relaxed way to get started into the question too, and it's so helpful. Then you can work out what are you doing. Okay, find the distance between them. You're just going to plug into the distance formula. So it's just good to do a bit of repetition, that's why we're doing so many. It takes a little while to get the hang of it. And to stipulate how important this substitution step is. So x2 minus x1 will be 3 subtract negative 2. 3 subtract negative 2. So I'm just reminding people, use the by doing this, I'm saying that this is the subtract and this is the negative button. There we go. So by that I mean your negative button for this, subtract button for that. So that's maybe a good thing, like we were saying before, to make a note of that. Plus y2, so plus, open bracket, y2 minus y1. So that's negative 4 minus 1. So negative 4 and subtract 1 squared. Plug it into your calculator. I won't do a demo again because I think you've got the hang of it by now. Write it out unrounded first, which is what I didn't do, but I don't have much space. Well, I do really. So write it out unrounded first and then round to 3 sig figs. So 7.07 units, it should be rounded to 3 sig figs. And we've got another example down here. Find the distance between these two. Just very straightforward still, but a bit of repetition can help. x1, y1, x2, y2. Feel free to pause and do this one yourself first, and then see if you get the same answer as me. So I'll just work it out quickly then, because you've had a few examples by now. Try plugging it in yourself, which hopefully you've done, and hopefully you wrote exactly this. 8 subtract 7 is x2 minus x1, and then negative 8 subtract negative 4. Negative 8 subtract negative 4 is y2 minus y1, all squared. And what do we get? Write your unrounded answer, and hopefully your rounded answer was 4.12. If you're finding it annoying not writing anything, you can always write the word units. Right, let's try something a bit trickier. Use the distance formula to determine if the triangle ABC, where A is this coordinate, B is this coordinate, and C is this coordinate, is equilateral, isosceles, or scaling. So if it's equilateral, what do you think will be the case with all three distances? That's right, they would all be the same. If they're isosceles, what would be the case? There would be two sides the same and one side different. And if they're scaling, what would be the same? What would be the case? It would be that all three sides are different lengths. So we're going to have to calculate three different lengths. We're going to have to calculate AB length, we're going to have to calculate BC length, and AC length, and see are they all the same, so it's equilateral, is there only two the same, so it's isosceles, or are all three lengths different? You could vaguely plot it, but on the graph, like you could always, this is another way you could check it. You could have a vague look at it, but it's pretty hard to determine. Like, you might think it's equilateral, but actually it's isosceles, or there's tiny, tiny differences between the lengths, and it's actually scaling. So plotting it on coordinates, the coordinates on a coordinate plane can give you a vague idea, but the only way you can really know is if you use a distance formula and calculate them. So that's what you should do. So let's work out AB length. So the distance from A to B, do your big square root sign. So you might want to label, for example, this is x1, y1. For this case, this is going to be x2, y2, but I didn't label that because it's going to change once we do a different length. So x2 minus x1 will be 2 minus negative 2 squared. Try putting in y2 minus y1. It would be 1 minus 0 squared. Write it out unrounded, and then to 3 sig figs it should be 4.12. Let's work out now what BC is. So BC, so now this would be your x1, y1, and this would be your x2, y2. So let's do a big square root sign. Feel free to work these out yourself and pause and just see if you've got the right answer. So x2 minus x1, 1 minus 2, all squared, plus y2 minus y1, negative 3 minus 1. Negative 3 minus 1, all squared. Write your unrounded answer, and then round it to 3 sig figs. So unrounded and rounded, it ends up being the same value actually, 4.12 if it's rounded. Now you've just got to work out AC. So at the moment it could be equilateral, it could be isosceles. We've ruled out scaling now. So we're just going to need to work out AC just to confirm if it is either one of these two. So AC, so now in this case it's x1, y1 here and x2, y2 here. And that's why I have that one finally labelled. And x2 minus x1, 1 minus negative 2, so be very careful with putting in your negatives. Y2 minus y1, negative 3 minus 0. Negative 3 minus 0, all squared, don't forget your little squares. When you plug that into a calculator, you get 4.24. So have a look. Is it isosceles? Is it equilateral? Yes, you're right. It is isosceles because only two lengths are the same. The other length is different. So write a little explanation, justification for your answer. So your working out is very important. You couldn't just say this and not have that working out. You wouldn't get any marks. So as two lengths were the same, it is an isosceles. Remember, spelled like isosceles. Isosceles triangle. Fantastic. That was a bit of a trickier problem solving one. Okay. Right, moving on to the next page. Another graphing one. Use the distance formula to show that the triangle ABC is right angled. So that's an interesting one. Not isosceles or equilateral or scaling, but right angled. So if A equals 1, 2, like for example x1, y1, B equals 2, 5, and C equals 4, 1. So what does the Pythagoras' theorem tell us? It tells us that in a right-angled triangle, so in a right-angled triangle, which is what Pythagoras' theorem applies to, what is the formula? It tells us that the square of the two legs is equal to the square of the hypotenuse. So we need to work out what these three lengths are first, and then plug them into Pythagoras' theorem after all that to see does a squared plus b squared equal c squared. So that's a lot of work. So if you do a vague plot of the coordinates, so you've got A, B, and C, I've just plotted these coordinates. Good to practice plotting. This is, after all, coordinate geometry. And then you have to work out the distances. So maybe pause and work out your distances. Work out AB first, so pause and work that out first, and then just check your answer with me. So I'll just very quickly erase this one now. I won't go through it because you know how to do it. So that's what you should have gotten for the first one. Next one, I want you to work out AC. Let's work out AC, and then we'll work out BC. So for AC, this is x1, y1, this is x2, y2, so they're labelled for this one. Pause and then work it out yourself and check your answer. Now which one is left? We've got to work out BC. So now this one is x1, y1, and this is x2, y2. So you might want to erase this and relabel this one. Do it all properly. Do labeling because it can mess people up if you don't. So hopefully you've paused and you've done it yourself, and now you can check your answer. So it turns out it's an isosceles triangle, but that's not what we're trying to find out. We're trying to test out, is it right angled or not? So I've kind of written a big blurb down here, which you can kind of pause and write out if you want. If you've got the space, you might want to summarize it. You don't need to write it in this much detail. So Pythagoras' theorem only works for right-angled triangles. So plug your answers to your three distances into a squared plus b squared equals c squared to see if this left-hand side, does it equal the right-hand side? And if it does, then it was a right-angled triangle. And remember, the c would have to be the longest side. So which one was the longest side? The longest side was the 4.47. So a squared plus b squared equals c squared. The two shorter lengths, 3.16 squared plus 3.16 squared. Ideally, we really should be using the unrounded answers. So if you want to do it with the unrounded answers, I think that's way better than what I'm doing here. Equals 4.47. Again, use the unrounded answer is way better squared. And you got 19.97, which is approximately equal to 19.98. If you use the unrounded answers here, you would get exactly the same answer, which is a better proof. So I would suggest you do even better than me, and you put in the unrounded lengths. So because I had rounded answers, that's pretty close. I believe that we do have a right-angled triangle, because we've shown that the left-hand side equals the right-hand side. This sign, by the way, means approximately equal to. So we've proven that it is a right-angled triangle. So left-hand side, I tend to write LHS, right-hand side, right, RHS. So it's a right-angled triangle because the three lengths satisfy Pythagoras' theorem. And Pythagoras' theorem only works for right-angled triangles. Let's do some more trickier ones on this last page. I think it is the last page. Yes, it is. So find B, given that A, the coordinate of A is 3 minus 2. The coordinate of B is B, -1, so we don't know what B is. And these two coordinates are this distance apart. So what they've done is they've given us the distance, and they want us to go back and solve. Using the distance formula, they want us to then go backwards and solve for B. So again, just label x1, y1, that's really important. The other coordinate as x2, y2. And let's plug this all into the distance formula. So distance equals square root of, and it's x2 minus x1, so just write b minus 3 all squared. Sorry, I just wrote the distance formula first, just in case you forgot it. You don't need to rewrite it again if you don't want, but you can. Might be helpful in your notes. So now let's plug everything in. So the distance is square root of 13. Let's replace that with the square root of 13 equals big square root x2 minus x1, so put in b minus 3 all squared. So you're probably guessing there's going to be a bit of foiling coming up, plus y2 minus y1, 1 minus -2 all squared. Bit trickier, this one. So how do we start to solve for this? So what I'd suggest is they've both got square roots on them, so why don't we just square both sides? If you square this side, you just get 13, because square root of 13 times square root of 13 is 13. If you square this side, it just means the square root's gone. So that's kind of nice in terms of solving. So now square both sides. That's what I'd suggest. So just to show the working out for that, maybe put that in brackets, square root of 13 squared equals, and then notice that the square root sign is just gone from this side, which makes life easier. And I happen to work out 1 minus -2 is 3, so that would become 3 squared here. You've still got your b minus 3 all in brackets squared right here. So what to do next, there's different ways you can kind of do it. You might want to write this out as double brackets and then FOIL it. So I'm going to do that, write this out as double brackets, work out with this answer, and that kind of thing. So now let's do that. So square root of 13 squared is just equal to, write out the double brackets, so notice that I'm putting in all the foiling business, b minus 3, just write out the double brackets, because that's important. People make mistakes if you don't do that, plus 9, and so on. So what I'd suggest is, what to do now? Maybe now subtract the 9 from the 13. So go 13 minus 9. You don't need to draw this big blue arrow. No need for that, to be honest. So now subtract 9 from 13. So basically subtract 9 from both sides. And maybe also FOIL this as well. So 13 minus 9, it's 4. So the 9 has been eliminated from this side as well. When you FOIL this out, you get b squared minus 3b. Actually, I've put it all together. I'm lazy. So I did b times negative 3 is negative 3b, negative 3b plus 9. So when you combine those like terms, negative 3b plus negative 3b is going to give you negative 6b. So once you've foiled this, you might have done the foiling off on the side somewhere. Once you foil this, you get b squared minus 6b plus 9. And that 9 was already subtracted from both sides, so we're good. Try to think what we would do now. What I'd suggest is you can probably turn this into a quadratic and solve it if you subtract 4 from both sides. Because remember, to solve the quadratic, it's got to be set equal to 0 first, the null factor law. So now subtract 4 from both sides, gives you 0. And then b squared minus 6b. What's 9 minus 4? It's 5. What can we do now? Now we've got a nice little quadratic, we could factorize and solve it. So let's just practice our factorizing. You could use quadratic formula too, of course, if you like. Now solve the quadratic. This turns out to be a nice one that can be factorized, so let's practice that. So 0 equals, open up your bracket, you're going to do your double brackets. So remember factorizing, what's two numbers that multiply to give positive 5 and add to give negative 6? So factors of 5, there's not that many. So you could get 5 and 5, or negative 5, 5 and 1, or negative 5 and negative 1. So 5 and 1 would give you 6 in the middle, but negative 5 times negative 1 would give you positive 5 here and negative 6 here, because negative 5 plus negative 1 is negative 6. So it's going to be b minus 5, b minus 1. So that's been factorized. So, and then solve. So remember, like just looking at this bracket, if b minus 5 equals 0, what's b got to be equal to? It must be equal to positive 5. Because positive 5 minus 5 is 0. And then if b minus 1 is equal to 0, what must b be equal to? It must be equal to positive 1, because 1 minus 1 is 0. So there's your two answers. So there's two possible answers for b. You can have b equals 5 and b equals 1. And what were we finding again? We were finding the coordinate of this point. And why can you have two answers? It's because, like, for example, if a was here, maybe b could be, for example, what it was b? B was an x-coordinate. So b could possibly be over here, or it could be kind of over here. You still have a length at the same distance. So long as you've kind of got from a, so from a to b, it's the same distance. So b could be here or here, for example. That's why it's possible to get two different answers for that x-coordinate. Here's another one where you're asked to solve for a coordinate. Find b given that 3 and b, a is that, b is that, and we've got a distance 2 units apart. So plug it into the formula again, and don't forget to label x1, y1, so important, x2, y2. Very important step. Let's start to solve it. So our distance equals big square root sign. Feel free to do this one yourself and then pause and check the answer afterwards. I'll erase nice and quickly. So plug everything in. Hopefully you had that. Then you can start to work some things out. So we could, first of all, if you like, square both sides. That's what I did, but you might have done it in a different order. That's fine. If I square both sides, square root sign's gone. And this negative 1 minus 3 is negative 4. Next thing what you might want to do, actually I'm just going to write that out too. Square both sides is what we did. So that squared just becomes that. Negative 4 squared, what's negative 4 times negative 4? It's positive 16, because a negative times a negative is a positive. Write out the double brackets now and start to FOIL on the next step. You might want to do your foiling off on the side, that's okay. Just make sure you get it right. Subtract 16 and FOIL. So subtract 16 because eventually we're going to have to subtract 16 from both sides. So 20 minus 16 is 4, so the 16's been subtracted off, it's not there anymore. When you FOIL, hopefully you got this. So I haven't done all the foiling completely because I haven't combined like terms. Combine like terms, that's what we have to do. So negative 2b minus 2b, what does that give you? It gives you negative 4b. And then remember before it's a quadratic again, so to factorize a quadratic we have to set it equal to 0 first. So we need to subtract 4. Sorry, I was having trouble with the eraser, so I just had to pause. So subtract 4 from both sides. So subtract 4, we get 0. And then you get b squared. I'm just putting the b squared first. So b squared minus 4b. And then because we subtracted 4 from both sides, there's no 4 here anymore. It's just b squared minus 4b. Now, good one to practice your factorizing again. Factorize and solve. I might need to scroll down a bit. Factorize and solve the quadratic. So we have a quadratic equation. You could use quadratic formula, but this is a nice easy one to factorize. So there's only 2 terms, so what's the common factor? Common factor is b. So we can write z equals b, 0 equals b. B times what makes b squared, b times b. B times what makes 4b, it's negative 4. Then you separately solve. So if, so here we've just got b equals 0. So that's what we've got. So b equals 0 is our first one. Should we do this one, b equals 0? If b minus 4 equals 0, what's b got to be equal to? It's got to be equal to positive 4, because positive 4 minus 4 equals 0. So as again, let's make a note of what I said before. There can be 2 answers. So write that down. So there can be 2 answers when you solve a quadratic. There can be 2 answers when you solve a quadratic. So that's why it's possible. So we've got b equals 0 and b equals 4. And again, it's because you can have 2 distances. So b is the y-coordinate in this case, so the x-coordinates are kind of fixed, but so the distance between them could be kind of like from here, it could be up here, or it could be down here, so long as the distance is square root of 20. So that's why we can have 2 possible answers, one where it's up here, one where it's down there. And that's the end of the lesson. Thank you.